Hi, today we're going to talk about rock abrasivity. Rock abrasivity plays an important role in characterizing a rock material for excavation purposes. The abrasivity of rock and even soil is a factor with considerable influence on the wear of tools. Hereby, the wear is a question of material consumption and to the excavation speed, which is an important indicator of rock excavation for tunneling, underground mining, and quarrying.
When we say abrasion, it can be defined as the wearing or tearing away of particles from the surface. Like for example, it is a process causing removal or displacement of material at a solid surface, which will lead to wear, especially on tools that are used in mining, drilling, and tunneling applications. The CERCHAR Abrasivity Test is a method to determine an index called CERCHAR Abrasivity Index or CHI for the rock's abrasivity. The test was originally developed for coal mining applications.
The CERCHAR Abrasivity Test is intended as an index for classifying the abrasivity of a rock material. The test measures the wear on the tip of a steel stylus having a Rockwell hardness of 55. A rock specimen, disc-shaped or irregular, is firmly held in the test apparatus. The stylus is lowered carefully onto the rock surface. While under a normal force of 70 Newton, the stylus is moved a total distance of 10 mm across the rock. The wear surface of the stylus tip is then measured under a microscope to an accuracy of 0.01 mm. The CERCHAR Abrasivity Index is a dimensionless unit value and is calculated by multiplying the wear surface stated in units of 0.01 mm by 10. For example, if the wear flat of a stylus tip was measured as being 0.25 mm, the corresponding value of CERCHAR Abrasivity Index should be reported as 2.5.
Now, let's go to the basic mechanism. There are two fundamentally different mechanisms to actuate the relative movement between the stylus and the rock surface. In the original CERCHAR design, both stylus and the dead weight are made to move across the stationary rock surface. In the case of the West design, the rock samples move under a stationary stylus. The main feature in the design of two test apparatus and the nomenclature of these apparatus are also offered. A consequence of the difference in design is a near tenfold difference in the test duration between the fast lever actuation with the CERCHAR design compared to the slow screw feed actuation with the West design. Both machines use a rigid vise to firmly clamp the rock sample. It is important to ensure that the apparatus is sufficiently stiff to minimize any lateral movement during a test.
Now let's go to the stylus. The stylus should be manufactured of a standard chrome vanadium alloyed cold work tool steel, which should be tempered to the desired hardness. It is strongly recommended to employ only stylite tempered to Rockwell hardness of 55. The diameter of the stylus should be at least 6 mm and its length shall be such that the visible part of the stylus between the pin shank guide and rock surface during a test is at least 15 mm. The tip of a stylus shall have a conical angle of 90 degrees. A worn stylus should be resharpened and the tip angle checked under a microscope before use in a further test.
The static force acting on the stylus should be 70 Newton. Each used stylus should be resharpened using a standard abrasive stone wheel. The grinding wheel should have a fine grit to avoid leaving rough surface at the stylus tip. The use of suitable cooling fluid that will prevent any change in stylus hardness as a result of grinding is mandatory. Now, let's go to the test procedure. Prior to the test, the stylus should be inspected under a microscope. The apparatus should be checked for proper functionality. The sample should be clamped firmly in the vise while observing the desired scratching direction. The rock surface should be, to the extent possible, horizontal. The stylus should be carefully lowered onto the rock surface to avoid any damage to the tip of the stylus. The stylus should be positioned so it is vertical and horizontal to the rock surface. The length of the test scratch in the rock sample must be exactly 10 mm. Depending on the apparatus designed, the testing duration is either 1 seconds for type 1 or 10 seconds for type 2 apparatus. During the test, there should be a constant contact between the stylus and the rock surface. Otherwise, there is more likely to be an erroneous result and the test must be repeated with a new stylus. After testing, the stylus is carefully lifted from the rock surface and the stylus removed. A minimum of 5 test replications must be made on the rock surface, each time by a new or re-sharpened your stylus.
Stylus wear measurement. The length or diameter of the wear flat D shall be based on the optical and digital methods using a microscope having a minimum magnification of 25 times. The measuring resolution should be at least negative 0.005 mm with readings reported to the nearest 0.01 mm. Measurements may be executed by side or top view settings. Measurements by side view are however strongly recommended. When testing a fresh fractured rock surface, especially in harder rock types, the wear flat can often exhibit a non-symmetrical shape with splinters or burrs of steel that stretch beyond the wear flat. These can affect measurements by making it difficult to determine the true diameter of the wear flat by top view measurements. A correct determination of the start and end points of the wear flat, as stated by Rostami et al. In 2005, is crucial to the accuracy of the test, which might otherwise contribute to large variations between different operations and laboratories. When using the side view method, it is suggested the stylus should be placed in a V-notch holder or jig, and 4 measurements shall be made each at 90 degrees rotation. The measurements should be taken parallel and perpendicular to the direction of scratching.
For the calculation, for each measurement of the wear flat, the chi is calculated by the formula chi is equal to d times 10, where d is the wear tip surface measured to an accuracy 0.01 mm. The dimensionless chi value is reported as the arithmetic mean of 5 or more test replications together with the standard deviation. Whenever a stylus hardness other than recommended hardness of HRC 55 positive negative 1 is used, the symbol notation adopted when reporting the chi shall be chi subscript x, where the subscript x denotes the value of hardness in units of Rockwell hardness HRC. The symbol chi shall only be applied to as measured value of wear flat on a stylus having a hardness of HRC 55 positive negative 1. If the length or diameter of wear flat on a stylus of a given hardness is known, then the equivalent calculated value of chi at the standard stylus hardness of HRC 55 can be calculated as chi is equal to 0.415 multiplied by chi subscript x divided by 1 minus 0.0107 multiplied by x, where chi subscript x is measured as the value of chi using a stylus having a hardness of HRC x.
Classification. The abrasivity classification system is given in this table. This classification system is based on the as measured CERCHAR Abrasivity Index or equivalent calculated CERCHAR Abrasivity Index based on stylus having a Rockwell hardness of 55 and a rock surface. The classification system must be not used for other values of stylus hardness.
The CERCHAR Abrasivity Index can be used then to estimate the life of the bead and the cost associated to it when conducted through different and various mining and tunneling applications.